Hey y'all, welcome back. Tonight's homework, we're solving quadratic equations using factoring, so we're going to see a bunch of examples of how to do this. These first few problems, luckily, are already factored to just kind of get you in the hang of what to do once you factor it. Number one says x minus 3 times x plus 1 equals 0. So notice how this quadratic has already been factored into its linear binomial factors. And once you've got that set up the way that this looks, we can use the zero product property, which states that as long as you have a product that equals 0, at least one of the factors must equal 0. So we can set each one of these equal to 0 and solve them individually. This is kind of the whole point of doing the factoring, is so that you can set it up so that you can solve linear equations rather than using quadratic formula or completing the square or anything like that. So here we've got x minus 3 equals 0, or x plus 1 equals 0. And so we know at least one of these have to be 0 because, like I mentioned earlier, the zero product property guarantees that one of these numbers has to be 0 in order for it to equal 0. So let's go ahead and add 3 to both sides here, and we're going to get x equals 3. And for this one over here, we'll subtract 1 from both sides, and we'll get x equals negative 1. So we really get two possible solutions here. If we plug in either of these two numbers back into the original equation, we will get a true statement. We can say that x equals 3 or x equals negative 1. Number 2, now this looks a little bit different than number 1, but it is still factored. It's just that the initial factor is a monomial instead of a binomial. But we can still use the zero product property here as well, where we can set each of these each of these factors equal to 0. So we have either 2x equals 0, or we have 3x plus 4 equals 0. For this factor on the left, we need to divide both sides by 2, which will give me x equals 0. Over here to the right, we'll start by subtracting 4 from both sides. So that's going to give me 3x equals negative 4. And then dividing both sides by 3, we get x equals negative 4 over 3. So once again, we get two solutions. I'm going to drag this down so I can just make one statement here. That x could either be 0 or x could be negative 4 over 3. All right, let's move on. Number 3 actually is not a quadratic, okay? I guess I let a cubic slip in here because we do have 3 factors instead of 2 here. But either way, we're still going to solve it basically the same way. We're just going to set each of these 3 factors equal to 0, because really only one of them needs to be 0. This first one would just be y equals 0, since it's just y by itself. If y was 0, this would be 0, and then 0 times anything would be 0. Over here, we've got y minus 5 equals 0. And then for the third factor, we have y plus 3, which would also equal 0. Could also equal 0. All right, so for each one of these, I'm going to go ahead and solve them. I'm going to drag this down because we're going to be able to do the other two in just a single step here. Y minus 5 equals 0. If we add 5 to both sides, we get y equals 5. Then for this third one, if we subtract 3 from both sides of the equation, we get y equals negative 3. Here we've got 3 potential solutions. So y equals 0, or y equals 5, or y equals negative 3. Now you could just list this, especially once you start getting more than 2 solutions. Definitely okay if you write it like this, like 0, 5, and negative 3. It's a little shorthand notation here, but I kind of get what you mean here. You're allowed to write it like that if you want. Number 4, now we're actually getting into the factoring. Okay, so 1, 2, 3 we're kind of set up for you already, but starting with number 4, you're actually going to have to do the factoring. And so there's a couple different ways to factor. Number 4, notice how there's no constant term. Right? We're not adding a 5 or adding like a number that doesn't have a p on it. So that's an indication that we want to try to factor using the GCF first, and potentially that's all we need to do before we start solving it. So notice here, both of these terms have a factor or are divisible by 3. Right? 3 is divisible by 3, 12 is divisible by 3. Then we can also divide out a p. So when you're factoring this GCF, you need to divide each term by whatever the GCF here is. And so 3p squared divided by 3p, you're just going to be left with p. And 12p divided by 3p is going to be 4. Now you can always double check and see if you did that GCF factoring correctly by doing the distributive property. Multiply this guy back in and verify that you are getting the original statement here. So 3p times p is 3p squared. 3p times negative 4 is negative 12p, so we are in good shape here. Yeah, when you're factoring the GCF, it's really just like doing the distributive property in reverse here. Now once we got it factored, we're going to split this up using the zero product property and set each factor equal to 0 and solve them independently. All right, what happened to my arrows here? They just disappeared all of a sudden. Don't really need them there, but I just think it helps kind of illustrate what's happening. Okay, so on the left-hand side, we're going to divide both sides by 3. 0 divided by 3 is just still 0, so p could equal 0. And on this next one, we're going to add 4 to both sides of the equation, so I get p equals 4. So p can either equal 0 or 4. Number 5. Now this one isn't set equal to 0. So one thing that hasn't really come up yet is that since we're going to use the zero product property as really the crux of how we're going to solve all these equations using factoring, we definitely need it to be equal to 0 so that we can actually use the zero product property. There's no like 5 product property or anything like that. It's got to equal 0. The first thing to do is to make sure that one side of the equation equals 0. So for number 5, I'm going to rearrange this a little bit by subtracting 16w from both sides. And so that gives me 2w squared minus 16w equals 0. Now I've got it set equal to 0. This is another one like number 4 that did not have a constant. So you can see how that's different than like number 6, which has this minus 15 here. So yeah, we just basically want to factor this using the greatest common factor like we did in number 4. Both 2w squared and negative 16w are divisible by 2w. That's going to be the GCF here. If I divide 2w squared by 2w, I get w. If I divide 16w by 2w, I just get 8. w minus 8 would be on the inside, and I can verify that I did that correctly if I distribute this in. So just keep in mind that you're allowed to do that. And now I can set each of these factors equal to 0. So 2w could equal 0, or w minus 8 could equal 0. Once I have those two equations set up, I can now solve them independently. For this one, actually this is going to be set up very similar to how number 4 was set up, once you got that equal to 0. But we're going to divide both sides by 2 here to get 0. Over here on the right, we're going to add 8 to both sides, and we're going to get w equals 8. Okay, number 6. So this is where the fun begins, where we actually have to do factoring that's not just GCF factoring. This is where we want to find 2 linear binomials that multiply to give me this. Okay. So one way to do this is to say, okay, well, first look to see whether or not the leading coefficient is 1. If it is 1, which it is in this case, then this is going to be one of our like easy factoring problems where all you have to do is find 2 numbers that multiply to give me negative 15. So multiply to give me negative 15 and add up to the middle term here too. Okay. We want 2 numbers that multiply to give me negative 15, add up to 2. And you might think for a little bit about what those might be. And then eventually, hopefully, you come up with the fact that it's 5 and negative 3. 5 times negative 3 is negative 15. 5 plus negative 3 is 2. Now, this little shortcut here only works if the leading coefficient is 1. We will see a few problems here where the leading coefficient is not 1. And then, I'll show you how to work those out as well. But if it is 1, then we can go straight to the two factors, which is m plus 5 and m minus 3. Notice that the plus 5 and the minus 3 are coming from these two numbers that we found over here. Now, those are not the actual solutions, though. We still need to set each one of these factors equal to 0 and solve it. So the first one would be m plus 5 equals 0. The next one would be m minus 3 equals 0. So for each one of these, we're going to solve them. This one we need to subtract 5 from both sides, so we get m equals negative 5. And this one is just going to be m equals 3. There's number 6. Number 7, we see we have another one that's not equal to 0, so we need to rewrite that so that we can actually solve this one out. I'm going to add 36 to both sides. Here's another problem where the leading coefficient is 1, so we can take our shortcut. We need two numbers that multiply, give me 36, and add up to negative 13. So since they multiply to give me a positive number but add up to give me a negative number, that tells me that both numbers have to be negative. So let's think of our factors of 36. 6 and 6, that, if both of those were negative, we'd get negative 12, so not quite. But 9 and 4 will work, or more specifically, negative 9 and negative 4. These are the two numbers we want. The order here doesn't matter. So if you do negative 9 and negative 4, you get the same thing as if you multiply 9 minus 4 and, I'm sorry, w minus 4 and w minus 9. So these are our two factors here, w minus 9 and w minus 4. And then I want to set each of these equal to 0 and then solve these. W minus 9 equals 0. And w minus 4 equals 0. So once I set each of those equal to 0 and solve them, this first one, I'm going to add 9 to both sides, so I get w equals 9. And over here, add 4 to both sides, I get w equals 4. Here's the two solutions for number 7. W could be 9 or w could be 4. Number 8, again, we've got the leading coefficient that's 1. Take our nice handy shortcut here. Since both numbers multiply to give you a positive 9, but add up to give you a negative 6, again, both of these numbers need to be negative. 9's pretty small, so it shouldn't take too long to find these two numbers, which would be negative 3 and negative 3. All right, so here we go. Our two factors here, p minus 3, and actually p minus 3 again. We will get two solutions here, but they will be the same solution. If you notice this, you don't have to set up two equations to solve. You can just do one of them. We get p minus 3 equals 0, and so adding 3 to both sides gives me p equals 3. All right, well, we just lost all of that somehow. I'm not sure where all X stuff went. But yeah, so we just get p equals 3. You only get one solution here, and that's fine. We do have a multiplicity of 2, although we're not really going to get into that quite yet. So there is some significance to the fact that this thing appears twice, the p equals 3. We're not going to worry too much about that at this time, but later down the line when we start talking about polynomial equations, that will become significant. Number 9, another one that's not set equal to 0, and it looks like this one has a leading coefficient that's not 1, so we are going to have to, we're not going to be able to take the little shortcut that we've been taking. First thing I'm going to do is set this equal to 0. All right, here we go. Here's how we're going to solve these ones that have a 5 at the beginning, okay, or really any number that's not 1. what we need to do is we know that this is going to be factorable into two sets of parentheses here, and we just need to figure out what those are. Okay, so there's a couple of different ways we could do this. I think what I'm going to do is do this little X box method that we talked about in class. So I'm going to start by using this X, which is kind of the same thing that we started with before, with this little shortcut. But here, we need to multiply A times C here. Okay, so 5 times negative 3 is negative 15, and that's the number we're going to try to add up or multiply to. Okay, 5 times negative 3. We were kind of doing that already, it's just that we were multiplying by 1, and so I didn't really mention it. We still need two numbers that add up to negative 2 here, which is that B term. So you want to think about this. This is kind of similar to one we already did, 15 and the 2. So here you have two numbers, multiply to give you negative 15, add up to negative 2 is going to be negative 5 and positive 3. All right, so now I'm going to set up my little 2x2 box here. This is going to be how I figure out what those factors are. There are some other methods, so if you have another way of figuring this out that works for you, by all means you can try that, but this is what works for me. So I'm going to put the first term in the top left box, this 5x squared. Then I'm going to put the constant term, negative 3, down in the bottom right box. And then in the other two boxes, I'm going to take these two terms that I found, and it doesn't matter which one goes where, but I'm going to put negative 5x in one of them and 3 in the other. So from here, what we're going to do is try to find, or 3x rather, is find the greatest common factor, the GCF, of each row and each column, and then we'll have our two factors written down the side here and up here. If I look at this first column, I'm noticing that the GCF is just going to be x. Okay? 5 and 3 are both prime. They don't have any common factors other than 1. But I could divide out an x out of each of these. If I look at the next column, my GCF is just going to be negative 1. There's really no common factor, but I could divide out a negative. And whenever that first term is negative here, you want to try to factor that out if possible. For this first row, the GCF here is going to be 5x. Both of those are divisible by 5x. And for the next column, the next row, these are both divisible by 3. So these are our two factors. It's going to be how you come up with those factors. We've got x minus 1, and we've got 5x minus 3. Plus 3. And you can double check and multiply those together if you want. We kind of already did that here with the box method to make sure that we actually got the correct factors, but those should be good. So now that we've got this factored, we can go ahead and solve it. You can say that either x minus 1 is going to equal 0, or 5x plus 3 equals 0. So for this one, we're going to add 1 to both sides. So I get x equals 1. On this right-hand equation, I'm going to start by subtracting 3 on both sides. Then I need to divide both sides by 5. So I get x equals negative 3 divided by 5. There we go. Those are our two solutions. So I'm going to use that method for, let's see, how many problems are there? I guess I'll use it for these top two, 9 and 10, this little X box method. When we get to 11 and 12, I want to show you a different method, and that way you can kind of see which way you like better. 10 is not set equal to 0, so we do need to do that. I'm going to subtract m from both sides. That is going to affect this 7m. When I subtract m from that, 7m minus 1m is going to be 6m. Oh, actually, this one doesn't have a leading coefficient. That's not 1, so we could take the shortcut on this one. So I take that back. We'll do the Xbox method on the next Here we're trying to find two numbers. Oh, this one's going to be easy. Two numbers that multiply to give me 9 but add up to 6. This one should probably be the easiest one on here, right? 3 and 3. And so my two factors here will be m plus 3 times m plus 3. This is another case kind of like, which one was it before? Yeah, number 8. That ends up only having one solution here. So you don't need to work it out twice because you can see the two factors are the same. So you just need to set one of these equal to 0. Subtract 3 from both sides, and we get m equals negative 3. For number 11, all right, now this one looks like it's going to be a problem like number 9 that has a leading coefficient that's not 1. However, we can make this a little easier if we just start off by dividing both sides by 3. Check this out. So we divide this side by 3, we divide this side by 3. And just like that, we're going to get rid of that leading coefficient. We have p squared plus 9p, I'm sorry, 3p. And then let's see, 120 divided by 3 is going to be negative 40. Ready? There we go. And then now now we've manipulated this so that it is just a leading coefficient of 1 type of factoring. So we can take our little shortcut here. Two numbers that multiply to give me negative 40. That add up to 3. Oh, those were kind of different. So let's see. I'm thinking 20 and 2 is not going to work. 4 and 10. No, I'm looking for two numbers that have a difference of 3. 4 and 10 is not going to work. 8 and 5. There we go. So it's going to be, they got to multiply to give me a negative, add up to positive 3 here. The positive one's going to be 8, and the negative one's going to be 5. Those are our two factors. We've got p plus 8 times p minus 5 going to equal 0. So now we can set each one of these equal to 0. So either p plus 8 is going to be equal to 0, or p minus 5 equal to 0. All right, so for this left equation, we're going to subtract 8 from both sides and get p equals negative 8. For the right equation, we can add 5 to both sides and get p equals 5. Those are our two solutions, negative 8, 5. Number 4, let's see, can we get away with dividing by negative 4 here? I don't think so, but we can at least make the problem a little bit easier by dividing everything by negative 2. So I think that might be the way to go here. It's definitely advisable to get that first term, at the very least, make it positive. It'll just make the factoring a lot easier if you do that. So I'm going to divide everything by negative 2. I'm going to force that leading coefficient. If I can't get it to be 1, I want it to at least be positive. And try to make it as small as I can. So now I've got positive 2b squared plus 7b minus 30 equals 0. All right, I've only had one opportunity to show you this Xbox method, so let's do that again. First, we need two numbers that multiply to give me negative 60. That's the a times c, 2 times negative 30. So two numbers that multiply give me negative 60 that add up, multiply to give me negative 60, they add up, give me 7. Ugh. All right, so let's think about this. Okay, so the fact that they multiply to give me a negative, add up to a positive, tells me one's positive, one's negative, with the positive one bigger. So what are our factors of 60? We got 6 and 10. Those have a difference of 6, so not or 4, so not quite. 5 and 12, I think will work. So yeah, my two numbers here are going to be positive 12 and -5. Those will multiply to give me -60 and add up to 7. So now, since this does have that leading coefficient, we do need to go one more step here to actually find our factors. Create this little box. And you can actually use this Xbox method on the easier ones, but it's just kind of overkill because you will get your two factors just immediately after doing this. So I'm going to put the leading term in the top left corner, constant in the bottom right corner, and then the other two corners are going to be, we're going to get from up here. So it doesn't really matter which one you put where. I'll put 12b here, put -5b here. So just like with number 9, get up here, we want to find the GCF from each column and each row. And these 4 terms that we write down are going to make up our two factors. So for the first column, the GCF here is just b. Can't really divide anything else out, so it's going to be b. This next column, let's see, so 12 and 30. I think it's just going to be 2. Just 2? Let me think. So if it's 2, that would make, if I divide both these by 2, I get 6b and I get 15. So actually, we can divide both of these by 6 now I'm thinking about it. So yeah, this is divisible by 6, that's divisible by 6. I think that's where we want to go, b plus 6. All right, so for the column, for the rows, this first one, both of these are divisible by 2b. Get 2b or not 2b. And then for this next row, we can divide out a -5. I think that'll all work out. My two factors here are b plus 6 and 2b minus 5. We're going to set each of these factors equal to 0 and solve them both individually. All right, so this one, we're going to subtract 6 from both sides, and we're going to get b equals -6. And for the second one, we'll start by adding 5 to both sides, which will give me 2b equals 5. And then divide both sides by 2, so I get 5 halves. Here's our two solutions, either -6 or 2.5. All right, so far so good, yeah? All right, we got 2 last problems that have fractions, and they look a little scary because of the fractions, but let's go ahead and clear the fraction. It's going to be a strategy that I like to use on all kinds of problems where I just don't really feel like dealing with fractions. So for this first one, what I can do is just multiply both sides by 2. Okay, so I'm going to just multiply this entire side by 2. Maybe I'll put parentheses around it and really just emphasize that, hey, I'm multiplying this whole thing by 2. I'm also doing the same thing to the right. I can't just multiply 2 to the left, so it doesn't really do anything because 0 times 2 is 0. But yeah, so now I've got this new equation, x squared plus 4x minus 12 equals 0. I'm going to do kind of the same thing to number 14. Right, so think about what I would need to multiply here to clear the fractions, and it would be 3. If I multiply everything by 3 over here, kind of getting both of these equations set up at the same time. They both involve fractions. And multiply this one by 3, this one by 3. Kind of give me a much nicer equation here. 2x squared plus 3x equals 14. And then, well, I might as well set this equal to 0, so that way we're just ready to go. 2x squared plus 3x minus 14 equals. Okay, so let's go back to 13. The 13, we want to try to factor this. The leading coefficient is now 1, so we can take our shortcut, find two numbers that multiply, give me negative 12 and add up to positive 4. Our factors of 12 are 1 and 12, 2 and 6, which that's it. Yep, we're going to have positive 6 and negative 2. My two factors here would be x plus 6 times x minus 2. Now I can set each one of these equal to 0 and solve them individually. X plus 6 equals 0 and x minus 2 equals 0. So subtracting 6 on both sides is going to yield negative 6. Over here, adding 2 to both sides is going to yield x equals 2. So we got our two solutions here. And let's go ahead and box our answer. Okay, number 14 is the last problem here. We already got it started, so at least it's ready to start solving. Let's go ahead and set up our little Xbox method here. Negative 14 times 2 is going to be negative 28. And then we've got 3 as our sum that we need. Okay, so let's think about this. Our factors of 28 are going to be 1 and 28, 2 and 14, 4 and 7 going to be our winner here. So yeah, 7, negative 4, which will multiply to give me negative 28 and add up to 3. I could set up our little box method here. Fun stuff. Once again, we're going to put the leading term, the 2x, to the top left box, or 2x squared. I just lost some of my lines here. I'm not sure what I'm pressing here that's making the lines disappear. I feel like this is the third time in this video where I clicked on something and then like a bunch of stuff disappeared. No big deal here though. Okay, so I put the leading term in the top left, the constant in the bottom right. And I just realized you probably can't see what I'm doing here, so I'm going to scroll up. All right, now these two numbers that we came up with before are going to go in these two boxes, 7x and negative 4x. The order here does not matter. You can swap these. You'll end up getting the same answer either way. But now let's pull out our GCFs. So the GCF of this first column is going to be 2x. The GCF of the second column is pretty obvious here. It's just going to be 7. Now for the first row, 2 and 7 are both prime, so it's just going to be x here for our GCF. And then for our last row here, we can pull out a negative 2. Now we've got our two factors here, 2x plus 7 times x minus 2 equals 0. And now we are on easy street. That's the hard part, is really figuring out these two factors. We're going to set each one of these factors equal to 0. 2x plus 7 equals 0, or x minus 2 equals 0. The first one, we'll start by subtracting 7 on both sides. 2x equals negative 7. Then divide both sides by 2, so I get negative 7 over 2. Then here we just need to add 2 to both sides. So 0 plus 2 is just going to be 2. So we get x equals 2. And that about wraps it up. Hopefully this was enough practice for you to really kind of get back in the swing of factoring. This is a very important skill, especially going into a college algebra class. So hopefully you're getting enough practice here. If not, you can always look online for more factoring practice. And I would recommend just do as much as you need to until you really get it down. So that's about it for today. Thanks for watching, and y'all have a great day.